here's the idea. So if you have, let me give you some motivation for this. This is pretty cool. If you have like x plus 2 equal to 0, if you have this equation, you could solve this, right? You could subtract 2. So you would get x equals negative 2. This is easy. That's called the linear equation. If you have like x squared plus 7x plus 1, what's this called? What type of equation is this? A quadratic, yeah. What can we always use to solve quadratic equations? Quadratic formula. Oh yeah, or completing the square. Factoring, it does always factor, but it's hard because you might have complex numbers. So we can do this. When we have x cubed, it's called the cubic equation. There's actually a cubic formula. I don't know it. I've never looked it up. I heard it was hard, and I just never looked it up. So they don't teach it at school anymore. I don't even know if they ever did. It's a pain. It's not fun. But you could solve it. If you have degree 4, it's called a quartic equation. It turns out there's a way to solve this also. You can use basic square roots and basic operations to solve quartics. So degree 1, degree 2, degree 3, degree 4 can all be solved with basic operations. There was this guy, his name was Galois, Évariste Galois, so it's Galois. And Galois proved that for 5 or higher, it's not always possible to solve these. So if it's quintic, which is degree 5 or higher, it can't always be solved. Some you can solve some of them, right? You could solve x to the 5th equals 1, right? That has 5 solutions, and 4 of them are complex. But you can't solve all of them. And he proved this when he was, I think, 20 or 21 years old. I think while he was in prison or before he went to prison. And he died from a wound that he got in a duel to the death over a girl. So he was in a duel to the death over a girl, and he was mortally wounded. And he created something called Galois theory, which is the study of solving equations and relating it to group theory, right? Really creepy. And he did it when he was 20 or 21. Ridiculous, right? So Newton's method is a way of approximating solutions. So because Galois proved that once it's 5 or higher, you're done. Like you can't always do it. So then Newton said, hey, wait a minute. Let's use some cool calculus to approximate solutions. So that's what this section's about. It's an approximation method. It's your first approximation technique. There's a class at UCF called numerical calculus. I never took it because it doesn't matter. But I never took it. I looked on my professor and the rating was bad, so I didn't take it. But it's calculus and it's all like this. Like it's all like approximation methods. So I don't know if it's cool, but I've never taken the class. This is an approximation method. So here's the pic. I'm going to be really careful with the picture. So this is the y-axis. Okay, and this is the x-axis. I wonder if I should derive the formula or if I should just explain the concept. The formula is really messy. I can just give it to you. I'll just give you the formula and explain the concept. And so here's a graph. I'm going to draw it very, very carefully. So here's a graph like this. Okay, and it keeps going, right? It keeps going. And this is C. Okay, this is C. And the goal is to approximate C. Because let's say we can't find it. Because it might be impossible to find it, right? Like Galois said, we don't know, right? It might not be possible to find it using basic math operations. You should look up his picture on the internet when you get a chance. His first name was Évariste. I think it's spelled Évariste Galois. I have a fake Facebook account, and that's my name. That's my last name on my fake account that I use for YouTube. Yeah, my first name is a female mathematician. It doesn't matter, but anyways, yeah. So the goal is to find, to approximate C. So the idea is that we make an initial guess. So we guess x1. So you literally just make a guess. Like you just guess. Like, oh, it might be 3, it might be pi. So I'm going to guess right here. This is our guess. And watch this. So now you look at the tangent line at x1. So if you look at the tangent line at x1, trying to be cheap here, trying to make it work on purpose. It crosses here. So you make an initial guess. Then you look at the tangent line at x1, and the tangent line at x1 crosses the graph, crosses the x-axis close to C. See how it's close now? So you make an initial guess, then you look at the tangent line at x1. And the tangent line at x1 will cross the graph, will cross the x-axis close to C. So then you call this x2. Again, you make an initial guess, then you look at the tangent line at x1. The tangent line at x1 crosses the graph close to C. And then you look at the tangent line at x2. And check this out. This is beautiful. Look at this. It's even closer to C. You see that? You see how it's closer now? It's beautiful. And then guess what? You do it again. And look at this. It's even closer to C. So what do you think you call this one? What is this one going to be called? x4. So basically you're just looking at the tangent lines. I'll draw it again so you can see it. So I'll explain it one more time. So here's C. And the idea is that you pick a guess that's close to C. So you say you pick an x1 here. So then this is here. And then you look at the tangent line at x1. And the tangent line at x1 crosses the graph here. So it's close to C. Then you do it again. Then you look at the tangent line here. And the tangent line at x2, again, crosses the graph. That's x3. And you just keep going forever. So the tangent lines, they just like get closer and closer and closer and closer. Does that make sense? Isn't that ridiculous? That's not Galois, that's Newton. By the way, this is the same Newton from what? What do you know Newton from? From physics. Yeah, he did the thing, what was it? F equals m times a. It's like the easiest physics. That's right. No, that is right. Yeah, it'd be really bad. mg. No, yeah. Well, I guess it's g if it's acceleration, but force is equal to mass times acceleration. That's the same Newton, right? The same Newton from physics. So the tangent lines get closer and closer to C. So that's the idea. Yeah.
Are the triangles that it makes between the points, are they like ratios in any way?
Oh, I don't know. I don't know. Maybe. I don't know. Yeah, it's an interesting question. I wish I knew. Yeah, I don't know. Yeah, there's a lot of stuff in this section that I've omitted too. Like, there's like all kinds of questions like when can you even use Newton's method? It doesn't always work. So this is rigged, obviously. This picture I keep drawing on the board. Unless it's the same picture every time. Look, I'll do it again. Look, one more time. Here's C. You pick a number close to C. You look at the tangent line there. Boom, it's even closer. Look at the tangent line there. Boom, it's even closer. And you just keep going. And you do it there. Boom, it's even closer. And every time, just boom, 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 boom. The tangent lines, it's like they're cutting, I don't know, like think of knives, like swords. It gets closer and closer and closer to C. So there's a formula, basically. All you have to do is use the formula. Okay, so let me give you the formula. So the formula, and then we'll do a problem. So the formula is x sub n plus 1 equals x sub n minus, it's a sequence. We haven't done sequences yet. You do those in Calc 2, but it's a sequence. It's a recursive sequence because the n plus 1th term is defined in terms of the previous ones. And it's f of x sub n, and the derivative goes on the bottom. So this is the formula. So this gives you the x's. There's all kinds of stuff you can learn. Like how if you want your approximation to be within like 3 decimal places, or if you want successive approximations to be less than 0.001, you could do stuff like that. However, in this class, I'm just going to straight up ask you. I'll give you x1, and I'll just have you find x2 and x3. So you just use the formula to make it pretty easy. Yeah.
Will the formula be given?
No, usually you have to know it. Yeah. Mm-hmm. Is that what you were going to ask also? Okay. Yeah. Mm-hmm. I mean, I guess I can write it on the board if you remind me. Do you want me to write it on the board? I mean, yeah. Just remind me. Okay. I mean, it's not a big deal. I mean, I don't really. It's recording. Doesn't matter. No one watches that anyways, right? AC. What's that?
The formula?
That's a prime.
So f prime?
Yeah, I feel bad now because you don't have to memorize it. But yeah, that's how I memorize it. The derivative is on the bottom, but you don't have to memorize it now. So. Why do you need to? I don't know. Why do you need to know anything, John? Why are we here? I don't know. It's an open question. I don't know. No, it's good to know. Why? So if you're going into engineering, this is the big deal because it's your first approximation method. A lot of your classes will be like the examples we're about to do, really tedious. You get some tedious computations sometimes. So it's a good introduction to approximations. Let's do an example. Let me see if I can find one. I'd rather do the one that's in my notes because it's already done. So I'm going to do that, and then we'll look at the homework later. Like I've done all the computations in my notes already. So let's do an example of Newton's method. So usually you have one of these on your test, just one. And usually everyone gets it right. The only mistake people make usually is they forget the formula, but I guess that can't happen anymore. So we have f of x. So now everyone should get it right probably. I think everyone will get it right now. So x squared minus 2. And they give us x1 equals 1.7. And we want to use Newton's method. So use Newton's method. Newton's method. And it'll be fill in the blank. So x sub 2, x sub 3. What does Newton's make you think of too? Like in terms of food, you know what I'm talking about? Fig Newtons, I know, I was just thinking. Yeah, you don't like them? No, I haven't had them in, I don't know, since I was like 10. I don't know. Like yeah, I had figs. They're all right. Like, really hungry now. Okay, so solution. So basically, the formula's gone. No, what did I do? Okay, so I'm going to write it again on the board up here. Oh, I'll write it here. So x sub n plus 1 is equal to x sub n minus f of x sub n over the derivative. So that is the formula. Hey! Next time is going to be different, by the way. Next time we're doing a really short section that's easier than this, and then we're doing integrals. Then after that, we're only doing one section. It's just integrals, I think. Then it's a review, then it's a test. So it's kind of nice. Oh, the test is fun. Okay, so I don't know. Let's see. I know. It's a good question. When is the test, right? I like how I can walk away and I'm not in the camera. What's that? 24? 25. Yeah. No, it's this month. Yeah, fun times. It's good. It's good for you. Unless the C thing comes, then, you know. So.
Wait, how do you take on
You're gonna make it really hard.
I don't know. We'll have to figure it out. I don't know. All right. So I'm allowed to give you one take-home test, right? Like they let me give you one. So
Can we make this one the test?
no.
Can you move to the final and take them?
Is this next test harder or easier than the one before?
Oh, everyone's listening now. That's a good question. Good question. Yeah. The hardest thing on this test is the integrals.
Okay, but is it going to be harder or easier?
I think it's harder because of the integrals. That's the only reason I think so, Nick. I'm being honest.
So practice.
Yeah, and that's why we have a whole day for the integrals. Like we have 4, 5 is only, we do 4, 1, 3, 3, 9, and 4, 1. 3, 9 is really short. 4, 1's all integrals, we do that. And then the next day we do 4, 5, and that's the only thing we do. And then after that we have a full review day. So, because, yeah. Okay, so f of x sub n basically just means that you plug it in here. So it'll be x sub n squared minus 2. Does that make sense? You just replace x with x sub n. It's really easy. And then I'm sure you know, if we had to find the derivative, ooh, challenge question, no, or not. What would be the derivative? 2x, yeah, 2x. So on the bottom, we would just get 2x sub n, right? Because it's just 2x. You just put the x sub n in here. So that's our formula. This is what we're going to use. I'm going to put this in a box. So when you're doing these on a test, step 1, just do this. The homework is a little bit different. The homework has a table, and they have you fill it in. We'll look at the homework when we're done with all this stuff. I'll go through all the homework with you. I'll show you how to do it. And the homework is annoying because it has a table and has you like do it in pieces. Whereas in the test, you can just use the formula. It's a little bit easier. Okay. Any questions on how we got this? Everyone see how we got that piece? So basically, you don't see it? Okay. So basically, you just put so this is f of x. So f of x sub n you just plug it in there. Replace x with xn. And then the derivative is 2x. So you just replace, you get 2x with 2xn. All right, good stuff. So we're going to look at x2. So x2, 1 plus 1 is 2, so n is equal to 1 when you're doing x2. Because look, if you put a 1 here, you get 1 plus 1. So you get 2. So when n is 1, you get a 2 here. Okay? So basically for x2, we're just plugging in 1. So you get x1 minus, and then we have x1 squared minus 2 over 2x1. Right, it's always 1 less here too. Look, if you look at it. When there's an n plus 1 here, there's an n here. So if this is x3, this is x4. No. If this is x4, this is x3. If this is x10, this is x9. It's 1 less. Just plug in 1.7. Yeah, it's really easy. So 1.7 minus, and then this is 1.7 squared minus 2. This is 2 times 1.7. Yep, totally. It's totally about the calculator. If you're really good and you know, I have my calculator. On the test, show some work, but you can actually program this into your calculator and just hit the button and it gives you the answers. You're allowed to do that. I mean, why not? I feel like if you have the skills to do that, you should be able to do it, so go for it. I had a guy in my class last semester, and he would do that. Nerding out, like he programmed it in his calculator. He's like, oh yeah. Let's do 4 decimals. I got 1.4382. Yep. Is that what you got, Aaron? Thank you. So then you would just come over here and fill in the blank. It'll specify the decimals on the test. Usually it's 4. So 1.4382. It usually makes like a 10-point question. That way to help you. You know, I'll try to remember. So don't type it in wrong. Don't forget like there's parentheses here, right? So you're really bad. All right. Now we got to find x3. So x3 is going to be same thing. Just plug it into, it'll be x2 minus, and then x2 squared minus 2 over 2x2. So just replacing all of the xn's with x2's. And then so this will be x3. So 1.4382 minus, and then same thing here, 1.4382 squared minus 2, and then 2 times 1.4382. Ridiculous. Very tedious. Very, very. You should see my notes. The ones I have in my notes are worse. Yep.
So you want us to use the approximated value, right?
Yes. Yeah, so use the previous answer. So it does create a dependency, so it's kind of bad if you mess up. So just be really careful and take your time. Make sure you're able to type stuff like this into your calculator. Yes?
If we mess up on, like, say, x2, but then we get the rest of them right, will we get marked off for each one that's wrong?
Not if I can see your work.
Okay.
Yeah, it's a good question, Sarah. So yeah, good, Sarah. So show the work carefully, and if you do that, I'll know your mistake and I can be lenient. Again, the most common mistake used to be people would put a plus sign here, but that won't happen because I'll give you the formula. So yeah, you should get it right. It's easy points. It helps. There's a lot of random stuff on this test that's not hard, and like Nick was saying, or he was asking, the hardest thing on the test is the integrals. But there's a bunch of other stuff. It's not hard, but you still have to know it, I guess. Yeah, there's parentheses here too on the bottom. There's like, you have to have them here and here in your calculator. So it's 2 times 1.4382. Wow. I got 1.4144. Yep. So you all got also? Yeah. Cool. Good stuff. Cool beans. No one says that anymore, right? Cool beans. You do? You say cool beans? Yeah. I was making a comeback? All right, cool beans. Yeah. I never actually said it, but I started to say it, I guess because people started to say it. So. That's Newton's method. That's it. So basically, you just use the formula. Let me explain something here. Check it out. Notice that you can actually solve this. If you graph this function, it looks like this. And this is the square root of 2. And this is negative square root of 2. And so see here, so the square root of 2 is approximately equal to 1.414213,562. And we got this. So this is really close, I think, right? Yeah, pretty close, pretty decently close. It's close. It's not super, super close. Okay, so it's close. It's close, right? It's pretty good. It's pretty good.
Why did you do that?
Just to show you that the goal was to approximate this. Yeah, so you basically set it equal to 0, and you're trying to find this plus or minus square root of 2. And so 1.7 is like over here. That was our x1. And so you do the tangent line thing. So, yeah. So,
I have another question, sorry.
no.
You said that we're doing the intervals not next class, but this class.
No, we'll do integrals next time and every time, actually, after today. Yeah, we'll be doing integrals every single day after today. Yep. Because next time we'll do 3-9, which is differentials. We'll do some integrals, and then we'll do 4-5, which is all integrals, and we'll review. We're not done. We'll do one more thing. Still one more thing. But you can leave, Reese, if you have to. Oh, does it work? Oh. We have one more thing to do.
Lesson?
Yeah, just more stuff, yeah. And then we'll look at the homework, yeah. Any questions on this one? I want to show you something cool. Like, you're supposed to learn stuff. All right, check this out. This is not even in the book, but it's in the homework, so technically it's part of the class, so let's do it. So, let's talk a little bit about fixed points. So fixed points, I'll give you the definition of a fixed point, we'll do an example, are a major research area in mathematics for some reason. And they come up, I guess, in different applications. I looked it up on Wikipedia and it told me what they were for, but I forgot. So let's talk about it. So definition. This definition is not in the book, but yet there's a homework problem that has you find a fixed point. So we're going to do it. We'll do that problem together. So a point x. So a point, and it's a number, but they're calling it a point. The reason they call it a point is because you can find fixed points in other areas of math, an example, topology. And in topology, elements in your topology are called points. So this definition is defined with that terminology. So they call it a point even though it's a number. So a point x is called a fixed point. This is really, really interesting. A fixed point of f if, and I'll even explain why it's called that. I don't know if it'll make sense, but this is why. If f, okay, so I don't know if you understand this knowledge, this terminology. If someone says fix epsilon, if someone says fix t greater than 0, do you all know what that means? If someone says that to you, like on the street, like, like, it means don't change it. It means fix it, like it's constant, like it's set, it's not a variable. So it's fixed, it's not changing. So it's a fixed point of x, of f, if f fixes x. So when you plug in x, you just get x. It's fixed. That's why it's called a fixed point. It doesn't change. Okay, that's my theory. I think that's why it's called the fixed point. I don't know, but that's the only way I can make sense of the terminology, right? So it's called the fixed point of f if f fixes x. It doesn't change, right? It doesn't change. So what does it mean? So, well, one thing it means is the algebraic interpretation. When you plug in x, you just get x. Graphically, it means something else. Here's the idea. So graphically, here's the y-axis, here's the x-axis. It's pretty cool. Like, we're doing fixed points in Calc 1. Like, who does that? It's so much fun. You do this in like advanced calculus and higher level math. Again, people do this for research. People who do this for a living. They drive to work every day and they think about how to approximate fixed points. Like, that's their life. That's their whole life. It's exciting. So you have a graph. This is just a function f. This is f. And so what is it saying? It's saying that f of x is equal to x. Well, x is just this line here, y equals x. So here's the fixed point. It's where they intersect. Now, of course, I could have drawn the graph differently. I could have done this. And then, in this case here, you have 3 fixed points. Oh, maybe, look, maybe 4. 1, 2, 3, 4. It's the x values, I guess, right? So the x value, the x value, the x value, the x value. So there's multiple. So a fixed point will occur every time they intersect. Boom, 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 boom. So fixed points occur when the graph of your function intersects the line y equals x. That's one way to look at it. Okay. Let's do an example. Just a simple example, not a calculus problem. Yeah?
If you have like a tangent function where you get asymptotes, but then...
Yeah. I guess, yeah, then you have to ignore that. You just focus on a specific place. Yeah. So like the tangent function, let's talk about that. That's really good. That's really deep. So let's do that example first, actually. Oh, because it goes up forever. Right, because if you have the tangent function, you have pi over 2, negative pi over 2, and then you have 3 pi over 2, and then you have negative 3 pi over 2. And it goes on forever. Let's talk about this. That's pretty deep. So this is tangent. I'm going to draw it. So he's asking, if you have the tangent function, how would you find the fixed points? Let's just think about it. So this is the tangent graph. It looks like this. So the problem is when you draw y equals x, it's going to cross a bunch of asymptotes. But I don't think that's a problem. That's a really bad graph. Y equals x would cross here in the middle. So one fixed point would be 0. And then the other fixed points would be like over here and over here. So it would be difficult to find them. But yeah, you could do it. You'd have to solve tan x equals x. That's a problem, right? I don't know how to solve that. I have an idea. We're going to use Newton's method. We can use Newton's method to approximate this. But solving it by hand, this might even be impossible to solve. I don't know. Yeah. So let's do an example that we can do, and then we'll do one we can't. We'll find the fixed point for cosine in a minute. That one we'll do. Here's an example that I got from Wikipedia because it was just easy. So we have a function, f of x equals x squared minus, hey, you're back, x squared minus 3x plus 4. And the question is to find the fixed point. Find the fixed point. It's kind of hard to find this stuff in books. So I was really happy to find an example on Wikipedia. I mean, I could have made one up too, but it's easier just to find one. Find the fixed point. Nah, she'll work. Oh, like the intersect command. Yeah, you can check your work that way. That's how I checked my answer. Okay, solution. SOL means solution. I don't know why I'm writing so big. It's not that hard, I guess. All right, so we were looking for a fixed point. So a fixed point means that f of x equals x. So step 1, we just write f of x equals x. That's a really bad x. There we go. That's better. F of x is just this. So you just replace f of x with what it is. So it'd be x squared minus 3x plus 4 equals x. And then if we have to solve this for x, what can you do next? What do you think? Subtract x, yeah. Set it equal to 0. It's a quadratic equation. To solve equations, usually you want to set them equal to 0 and try to factor or something. Negative 3x minus x is negative 4x. This should factor because it's a math class and it's rigged. This example is rigged. This is x minus 2. It's from Wikipedia. That's why I chose it. So this factors. It's x minus 2 squared. So x is equal to 2. That's it. That's it. We found our first fixed point. So it's really easy. So to find the fixed point, in theory, you just take the function and set it equal to x. You can see how it could be difficult, though. Like Jonah's question, he was saying, what about tangent? Tangent of x equals x. This is hard. Right? I mean, it's a trig function equal to a polynomial. No. Right? Newton's method will give us an approximation. Newton's method lets us approximate impossible equations. Equations that are impossible to solve, we can approximate them with Newton's method. So that's, John had asked, what was it for? That's one application of it. It lets us approximate solutions that we can't actually do, that are just not possible mathematically. You could check that it's a fixed point. If you plug 2 back in, let's do it, just for fun, and then we'll do one problem. You would get 2 squared minus 3 times 2 plus 4, by plugging the 2's in over here. So you would get 4 minus 6 plus 4. So you get minus 2 plus 4. So you get 2. Boom! So f of 2 equals 2. So f fixes 2. So 2 is a fixed point, so it checks. So really cool, right? It's really easy to do. And again, what is this for? What do people use this for? There's all kinds of applications. According to Wikipedia, I'm not an expert on fixed points. I proved some fixed point stuff because I had to in classes, some classes I took. There's always like theorems, all kinds of fixed point theorems. They all have names, and you study them, and you take a test, and you use them on the test. But like, I never did anything with them, and I never did any applications with them or anything. But yeah. So let's do an application of one now, like something decent. Let's find the fixed point for cosine. Let's find that. This is actually an important number. Like mathworld.com has an entry for this question. Like the fixed. That's how I found the answer initially. I Googled it and it showed up. So we have f of x equals cosine x. Find the fixed point. Let's find the fixed point for cosine. We're going to approximate it. We'll do 2 iterations of Newton's method. So we'll find x2, we'll find x3, and we'll call it a day, and it'll be good. And it's nice because we're going to do this from scratch. Like, there's no x1 here. We're just going to come up with it using our minds. So it's kind of cool. It's like, yeah, we're just going to like do it, you know, the way Newton intended, maybe, or something. I don't know. It's kind of like raw solution. So I guess we have to have f of x equals x. So let's try that. I haven't done this in a while. It's going to be kind of fun. That's the goal. That's the goal. So let me get this impossible equation for cosine x equals x. Like, I'm pretty sure you can't solve this. I don't think it's possible. Cosine x equals x. So Newton's method helps us find solutions to equations. When we use Newton's method, like if you think about the last example we had this. And we basically approximated this. But that's when it's equal to 0. Basically, it helps us find things that are equal to 0. So to set this equal to 0, maybe we can subtract cosine x. So let's focus on this. You see, because in the previous example, we had x squared minus 2. It was, you know, and then when the answer we found was an answer that approximated this solution to this equation, right? So same thing here. So now we need to give this a name. Because here we called it f. So here we need to give it a name. But we can't use f. So let's call it g. So now we're going to use Newton's method on this new function. Because now it's like the previous example, x squared minus 2, where we approximated the x-intercept. That's what we want to do here. So now we're going to use Newton's method on this. So use Newton's method. I'm thinking about figs again. Newton's method. Are they really gross, the figs? You don't like them? I'm trying to remember the taste. Okay, so we need an x1. So how do we do that? I guess we have to think. Let's think about the graph of cosine. Cosine of 0 is 1. That's how I always start the graph of sine and cosine. I think about what happens when you plug in 0. So it starts here. If it was sine, it starts here. So it does this. And then it does this, etc. And then y equals x is here. Does anyone know what this is? Pi over 2. If you were, so we have to figure out this here. Right, this is what we have to figure out, this value. This is the fixed point right here, fixed point. That's our fixed point, this little piece right here, right, where it crosses. So pi is like what, 3.14, etc. So pi over 2 is like 1.57. So how about we just go with 1.5? We can go with 1. I wonder what I used in my notes. No, I used 1. You want to use 1? Because I used 1 already. Let's use 1. Let's use 1. Save some calculator time. Sorry. Yeah, I don't want to redo the computation. It's ridiculous. So I'll use 1. That's close enough. 1's like right here probably. So now we can use our formula. So x sub n plus 1. You can use 1.5 too, by the way. It doesn't matter what you use. It should work. Like you should still get the same answer roughly. So x sub n plus 1 is x sub n minus, oh, I almost messed up. I almost messed up. It's g of x sub n over g prime of x sub n. I was going to put f. I don't want to lose points. Have I made any mistakes today? Not today? Sorry. Huh? You think I will? No, I won't. I won't mess up ever again in this class. No, you don't need them. You see, okay, so this is x sub n plus 1 is equal x sub n minus, if no one got any extra credit points, by the way, I'd probably put an extra credit question on the test, you know, so just for fun. Oh, I totally have all kinds of questions I could put on there. Yeah, just to see if you could do it. Anyways, so you plug it in here, so you get cosine of x sub n minus x sub n. Oh, you take the derivative. What's the derivative? I'll do it here. G prime. What's the derivative of cosine? Negative sine. Yeah, good. Negative sine x minus 1. I've made mistakes on this question before, like a lot. It's really easy to mess up. And then you just take the that and put it there. So like this. Really nasty, right? So we took the derivative of this. That goes on the bottom. That's the g prime. Replacing x with x sub n. Now we can plug in our 1. You want to make sure you're in radians. So x sub 2 is equal to 1 minus, and this is cosine of 1, minus 1, negative sine 1, minus 1. Right, because it's x1. x1 is 1. And I did this before in class in a red pen for some reason. And I got x sub 2. The question doesn't say anything about decimals, so I'm going to write all the decimals I got. I got 0.75, 0.366, 38678. Really? Wow, that's so cool. I copied them all down, right? I mean, that's really good. Yeah. And then I don't want to do the other one. We'll just stop at x2. If you're curious, I worked out x3 as well. It's 0.7391128,909. To find x3, you would take this decimal and you'd plug it back in here. Yeah. And yeah.
So is that our fixed point?
Yeah, so you could use this one or this one. It doesn't really matter which one. Yeah, use this one. The actual fixed point, like from the internet that I got from like mathworld.com, is 0.7390851,332. So it's really close. It's really close to the number that I guess computers can give you. So it's really close. I don't know if computers use this to do, I don't know. I don't know how computers do it. I don't know if they, I don't know. Yeah.
It's all learning.
Yeah, I'm going to go over the homework now, though. But yeah. Yeah, that's everything. Yeah. So, you leaving? Oh, have fun. Where do you work? Chick-fil-A. Oh, yeah. No, it's good. No, hook up. No, I'm kidding. No, like, discounts. No. Yeah, I'm kidding. Yes.
I'm getting 0.91.
Are you in radians?
No, I'm in.
Oh, you want to have parentheses. You're missing a parentheses in the bottom there.
I did the parentheses.
You're missing one up top also. Wait, no? No, let's see. 1, cosine 1.
Parentheses are the yin yang. So we have parentheses, cosine 1, parentheses.
Hold on. Cosine 1, so it's this. You have 2 negatives on the bottom?
I did divide it by negative
Yeah.
sine.
Yeah, try that.
I did.
Do it again. Are you in radians?
No, I'm in degrees.
That's why.
Oh, I need.
Yeah, you want to be in radians. Yeah. Mm-hmm. You want to be in radians. Yep. Yep, see ya. Any questions on this? Yeah. Yeah, we're done. I'm just going to look at the homework now. Mm-hmm. No questions? Any questions on fixed points? Anyone think it's cool besides me? Fixed points? Yeah? Oh. Oh, because this is the actual, if you solve cosine x equals x, you'll actually get this apparently. So this is really close to this. This is our answer, so our answer is like really close to the actual answer that you would somehow get. Mm-hmm. Yeah, you had this homework, yeah.
So those are like approximations
Of that. Yes. Yes, John. Good, John. Yes. These are approximations of, like in the previous example, we had, our answers were approximations of the square root of 2. We were approximating the square root of 2. Mm-hmm. Yeah, it's cool, right? And this is a thing that comes up in applied math, so I figured we should see it. So
3.7.
yeah, let's look at that. Yeah.
So say we did like x10, would it be like super close?
I guess so. I guess it keeps getting closer. Yeah, I think it does. I think the further you go, the closer it gets. Not always, though, but I think it's supposed to. And Newton's method doesn't always work either. Like, if the derivative is 0, game over. Yeah, the book has like a condition like that, says Newton's method works if this is true, or etc. So
on the test, it wouldn't be like that.
no. On the test, it's just fill in the blank. All right, turn this off.